Today's day 3 of Unit 11 on comparing functions. So we're just going to go over the homework and then we will go into today's lesson. So number 4 for yesterday, some of you are having trouble with this, so let's talk about it. So I noticed that first you guys tried to add, then you tried to do the double difference, and that didn't work. So the last thing you got to check is if you can multiply. I understand it's not going to be a whole number, but remember that you can go backwards. So you know it's multiplication forward, so if you go backwards, you would do 180 divided by 120, it would give you 1.5. And if you did that for all of them, you would see that the common ratio is 1.5. Now, in order to put this into an equation, you would need to figure out what the y-intercept is. Well, to figure that out, they didn't give you 0, so be careful. A common mistake is to put 120 in where 80 was, so that's going to make this answer incorrect. So just make sure that you would do 120 divided by 1.5, again working backwards, and you would get 80. So at 0 weeks, there's 80 downloads, so basically that's how many were there to start. And you substitute in your formula, and then it wanted to know specifically at the 26th week, so that's why I labeled this x and y. Remember, time is always going to be x, right? So that's always going to be your exponent. And then to figure out what the downloads are, you just have to substitute that in. So this is just a very simple calculator. The second part would just be something you did in your calculator. So you would just make sure you raise 1.5 to the 26th power and then multiply it by 80. Again, make sure you don't multiply 80 times 1.5 first. The only thing being raised is 1.5. Alright, the next one was number 5. And I felt the easiest way to do this was by making a table. So once I made the table, because they told me, you know, one rental, you know, the first movie, the second movie, and so on. So at 0 movies, we started with $175. So you can see that they're spending they're taking away $2.75. So remember, you could also write y equals mx plus b. So m is going to be our rate of change, and b is going to be our y-intercept. Okay, and then they just wanted to know how many weeks can she afford. So opposite of the last one, we want to make y equal to 0 to figure out how many weeks it would take. Again, the reason why they used a sub n is because they told you to up here. Okay, so think of, so a sub n is equal to like f of x. Okay, so this is just notation. They want to make sure you can put the notation in. So yes, you did have to use the variable n just to put it in the notation they wanted. Okay, number 6, the answer was 4. Again, you just had to find the pattern. Remember, when we see compounded annually, you should automatically be thinking exponential. All right, and we are depositing, and you can see clearly that the numbers are going up, so it's going to be growth. And lastly, number 7 was 3. So the first one says compounded annually, so that would be exponential. This one says the word double, so that's also going to be exponential. And then the concentration of a person, so decay, exponential. Okay, so 3 is the only one that makes sense. Alright, so today is basically a review lesson. We talked a little bit about this when we were graphing quadratics. So today we're going to focus on how do we solve a quadratic linear system graphically. So remember, you always want to extend your quadratic or your parabola as far up as you can. And the only way that they are not going to have a solution is if they do not touch. So remember, just because, so if my line was up here like this, let's say they're not actually touching, well, remember, I can extend my parabola. So if I can extend my parabola or my line so that they do intersect, there is a solution. So always check on your graph and try to extend your table or your graph as far as you can when you put those on a coordinate grid. So your options, pay attention to this, because if this is a multiple choice question, there's got to be 4 different answers. So if they ever give you something that's not 0, 1, or 2, so let's say 3, do not pick 3. That is impossible. Okay, a linear and a quadratic can only intersect twice, once, or 0 times. All right, and then make sure that you check. Okay, so number 1, we're going to let f of x equal negative x squared plus 2x plus 4, and g of x is going to be negative x plus 4. So put them into your table on your calculator. And then the second question asks, we want to state all the values of x when they are equal. So all this means is where they intersect. All right. So, you know, when I do these videos, it takes a long time to graph, so I did it in advance. Okay, so for the first one, for the quadratic, and remember, please make sure you label each of your lines. At the very least, do f of x and g of x if it's a small graph and you can't fit it. So my table is for my quadratic. As you can see, it's symmetrical. For g of x, you could do the same exact thing. I just use the slope and the y-intercept. So remember, if you start at the y-intercept, you use the slope. So you go down 1. So remember, this means either down and to the right, or you can go up and to the left. Okay, so we just do 1, 1. So 1, 1, 1, 1. Remember, this is a negative slope, so you know that your line is going to be like that. My parabola is negative a, so you know, just think of those things before you actually do your work, because that's just going to be so much more helpful, and you can double check your work before you even do anything. Lastly, we want to figure out our solutions. So notice that the question, and we've talked about this in the past, but notice that your solutions, if you look on the graph, so be 1, 2, 3. So 4, 0 is one solution, and 0, 4. Sorry. And 1, 2, 3, 1. Okay. Now don't put this in the bottom answer, because that's not what it's asking for. It just wants to know when f of x and g of x are equal for all values of x. So you're just going to say, so x equals 0, x equals 3. That's your actual solution. If you want to write it as a sentence, the two functions are equal when x is 0 and x equals 3. That's all they want. They don't want the actual coordinates, so make sure that you read it. All right, now this one's a little bit different. This one wants you to graph the functions and then determine and state all the values where the equations are the same. So again, when we're solving systems, so multiple functions on a graph and where they intersect, make sure you read. Right? This says all values, so they do want the intersection points. So again, just separate them into 2. So you can put this one in your calculator, get your table. And then for this one over here, remember y equals mx plus b. So you always want to get y by itself. So this is what you would graph. So just be careful with that. Alright, so here are my solutions. Again, if you want, I use my slope and my Y-intercept to graph my lines. If you want to just make a table, go ahead and make a table in your calculator. But remember, again, B is 6, so we start at 6. Where is it? Okay, right here. So we start at 6, and then we go down 1, 2. So this is up and to the right, or down and to the left. Okay, so you could do negative, negative. Remember, a negative divided by a negative is a positive. So if you wanted to go down 1, 2, just make sure you go left 1. Down 1, 2, left 1. Again, my slope is positive, so my line should look like this. My parabola is positive with the leading coefficient, so boom. Now this one, again, I told you it said to find the solutions, so it actually wants the coordinates. As you can see on this graph, it's a little bit off. Just make sure that you are, connecting your dots. If you look really close, like this is kind of off when I connected it. Make sure you're using that ruler, because if I did connect them better, that does go through that line. Okay, so just be careful when you graph those. Make sure that your intersection points are very clear, and make sure, now the parabola, obviously it's a smooth curve, so you got to do the best you can, but with that line you can use a straight edge, so make sure that you do. Alright, number 3, we have to do a little bit of solving again. So again, your first thing is always separate them so that you can keep them nice and organized. And then if they are not solved for y, that should be your first step. Okay, you cannot graph them otherwise. It needs to be like this. Okay, so I'm going to subtract x. So I get 2y equals negative x plus 4. Then I'm going to divide by 2, and divide everything by 2. So the way that I'm going to write this is, you can either write negative x over 2, or, remember this is a 1. So I'm going to write negative 1/2 x plus 4 divided by 2 is 2. So this is actually what I am going to graph. Okay, so here is all my work. Again, so all this right here, this is the axis of symmetry. Sorry, I've been doing that on all of them and not pointing it out. Okay, so the axis of symmetry just kind of shows you where it should be symmetrical over. You don't have to do that every time. Just thought it was a good review. Just put down your coordinates. Make sure that you find the vertex so that it's nice and symmetrical. And then if you are using a table, this is probably an easier way to put in negative 1/2 x plus 2. You can change your fraction into a decimal. Also, what I wanted to go over was how you can check your coordinates in your calculator. Because remember, so if you looked at this, you might have only done 4, 0, but it actually crosses through twice. So just because it's not a whole number, it doesn't mean it's not a solution. It just means that it's a decimal. So I just wanted to go over that, how to find that really quickly. Okay, so I put the functions both into my calculator, and we are going to use them to find that second point. So I'm going to hit graph. Okay, you can clearly see on the graph that it crosses through twice. Now 4, 0, I can get that right from the table. Okay, I can get that right from the table. But as you can see, I can't see the other one. But I know that there's definitely 2 points. So what I'm going to do is I'm going to hit second, and then trace goes to calc. And then I'm going to go to intersect. Alright, so I'm going to scroll down so it's kind of closer to the intersection point. So I'm going to go to the first curve, which is my parabola, and we press enter. And if you look up at the top, it tells you what curve it's on. All right. Then I'm going to go to the second one. That looks pretty close to the point, so I'm going to press enter, and then don't worry about a guess. Okay, so it gives me my exact intersection point. Sometimes it might round it. This one was a perfect whole number, or a terminating decimal, so it gave you an exact. But if it doesn't, you can round it depending on what the question says. Okay, so again, that was second trace, which second trace, that's, you're looking for calc. Okay, and then you hit your intersect. All right, the last one I'm going to do with you is number 4. So as you can see, we do need to solve each of these. So y minus 7 equals x squared plus 2x. And then y minus 7 equals, oh, yeah. I said it right, I just wrote it wrong. Equals x. So I'm going to add 7 to both sides. And then you can graph each of these. And here's my final answer. Okay. Again, I showed you my axis of symmetry. Don't need to put it on there. You can clearly see that it intersects at -1, 6 and 0, 7. If you had both of the tables, you could also, extend it and, make your quadratic y1, your linear y2. Put your tables right next to each other, and then you can clearly see if it was -1, 6, it would also be a 6. At 0, 7, it would also be a 7. All right, so for the rest of class, I would like you to work on numbers 5 through 8. Okay, and you are finding the solutions. Okay, so again, this is just practice with your graphing. We've taken a little break from graphing, so I want to get back into it. So find the solutions, give as coordinates.